Okay, so basically, I already mentioned basically in your past paper. So your past papers or your normal paper is like this, that one question is specifically from one chapter, right? Just like the
Yeah.
chapters are kinematics, work energy, power, elastic deformation, and physical quantities and measurements. So four questions are from that. Then we have wave and superposition. So these two chapters are making one question of your paper, right? And you see
Yeah.
that this question is of total 10 marks, right? So we only discussed half, one chapter means half section of wave. So first question is related to stationary wave, and we know that this is a topic of second chapter, superposition, right? So we are not going to solve this one. We also not discuss this topic. This is also from your second chapter, right?
This is all superposition.
Yes. So
Okay.
this is from second chapter because there is a mixed content in your paper because you need to study all of them, right?
Yeah.
Okay. So now first part, yes, this is from our chapter of waves. This is related to which topic?
Frequency.
Yes. So basically it is related to a motorcycle traveling. So basically this is related to Doppler's effect, right? Because there is
Okay.
motion. So let's first try to solve this one, then we will move towards the other part of the question. Okay, so a motorcycle is traveling at 13 meter per second along a straight road. The rider of the motorcycle sees a pedestrian standing in the road directly ahead and operates a horn. So now we are having a sound wave, right? So
Also, in this paper, they said three significant figures.
yes, sometimes this specifically asks. Otherwise, you know that normally we need to shift our numbers to two significant figures, right? But this time
Yeah.
asking three significant, because normally when we are writing frequency in these topics, so normally we write in three significant figures, just like the wavelength of sodium light and these type of things. So normally in a standard form we used to observe they are in three numbers, three significant figures. So that's why they ask three significant. To emit a warning sound, the pedestrian hears the warning sound from a horn at a frequency of 543 hertz. The speed of the sound in air is 334. Okay, so we know that a simple speed of sound is equals to V from the formula, right?
So
Uh,
what we're gonna do is we're gonna do 543 multiplied by 334 divided by 334 plus 13.
so basically, this is our formula, right? We discuss,
Yeah.
and we are going to use minus or plus. That is a question.
I think plus because it's going towards.
Okay, confirm.
No. It's you're gonna use negative because when you're moving towards, it's gonna be negative, but when you're moving away, it's gonna be positive, right?
Yes. So we are going to use the negative one. Now we need to substitute the values, right? So this 543 will be F naught or F.
543 is going to be FS.
Confirm that. Okay. Again, read from the second line. The motorcyclist sees a pedestrian standing in the road directly ahead and operates a horn to emit a warning sound. So this story is end for the motorcyclist, right? He just
Yeah.
operates a horn and there is no frequency mentioned. It means there is no source frequency mentioned in the question, right?
Okay, so
The
it's gonna
pedestrian
be
hears, yes.
observed.
Yes, it is observed because it is mentioned here's the warning sound. So it means that it is observed frequency, right? So you see that how statements are confusing. We know the concept, but the statements are confusing. So that
Yeah.
will take time. But the speed of sound is 334. So we know all the things now. And this will be Vs because this is the speed of source. Now simply you can easily solve the question, right? So 543 is equals to Fs will be unknown multiplied by 334 divided by 334 minus 13. So just calculate the final answer. From the
Okay.
marking scheme, I am writing the answer. You may calculate by yourself, right?
Yeah, okay.
Actually, you will get first
I got
521.
521. Yeah, I got 521.8, so I'm gonna make it
Yes.
522.
Okay, so you know the concept that you need to transform into three significant figures. So we are going to round up 522.
Yeah,
So
522.
yes, so that is our first part. Now the second part is the motorcycle rider passes the stationary pedestrian. Okay, so observer is stationary and then moves directly away from her. Now it is moving away from her. First it is moving towards, now it is moving away. As the rider moves away, he operates the horn for a second time. Again he operates the horn. The pedestrian now hears that sound increasing in frequency, right? State the variation, if any, in speed of the motorcycle. So main question is related to the speed of the motorcycle when the rider operates the horn for the second time.
Isn't it the same?
It will remain same.
And
Okay.
then he moves directly away from her,
Yes.
and then he operates the horn the second time, right? And then it feels like it's increase in frequency,
Yes.
but that means that if the frequency increases,
Yes.
the wavelength will decrease,
Yes. Wavelength will decrease.
but then the speed will be constant.
Speed will be constant. Confirm.
I don't know.
Okay.
That's the
Okay, so basically in this question there is a different scenario, and scenario will be like this, that now it is going to move away from the rest or stationary observer, right? And second time he operates the sound and the frequency is observed by the observer, that is in increasing form. So state the variation, if any, in the speed of the motorcycle when the rider operates the horn for the second time. So we know frequency increase and wavelength will decrease. That is from the Doppler's effect. So we know the concept. And the next thing is the pedestrian now hears the sound that is increasing in frequency. As the rider moves away, he operates the horn. Okay. So increasing frequency means decreasing wavelength. So state that variation, if any, in the speed the motorcycle when rider operates the horn for the second time. Okay, so now we need to find the variation. Now let's try to figure out the same concept. Let's suppose this is a stationary source, and when it is tried to move towards the observer, or sorry, away from observer. Let's suppose observer is in this direction and it is moving away. So your final observation will be like this. Uh, this will be much greater. So when source is moving away, so what actually happens over here, that your wavelength decreases or increases.
wavelength increases.
So actually wavelength is going to be increased. So frequency must be decreased over here, right? But what is mentioned in the question that the pedestrian now hears the sound that is increasing in frequency, not in wavelength, right? In this situation, we are getting concept that wavelength is increasing, but frequency is going to be decreased because now we are moving away, right? But now we are having a different scenario over here that your frequency is increasing. So it means that your wavelength will decrease. But original situation, we are having opposite condition, right? So that's why there is a question that what will be the change or what will be the variation, if any, in the speed of the motorcycle. So that's why they are asking. And it only happens if we decrease our speed, right? Because if we move with a greater speed, so we just quickly pass through that observer and our wavelength will automatically increase, right? But let's suppose if we are passing away from the observer and if we slow down our speed, so these wavelength will be shorter, not as much greater, right? Because they not mention it is moving with constant speed, right? It is not mentioned. Okay, are you getting the concept?
Yeah.
Any confusion?
No?
Okay, since we are moving with a greater speed, so there will be a greater wavelength, but they are asking about the variation in speed. So variation will be the speed is decreasing. It means that when we are passing from the stationary pedestrian, we are going to decreasing the speed. Let's suppose if someone asking for a lift, so after passing through that, we decrease our speed, right?
Right.
So this is a condition like this. So that's why they are asking about the speed, right? So always try to relate the original condition with the given condition in your question, right?
Speed decreases because,
Yes, because in question they mentioned that your frequency is increasing, but in original case, this is a case of moving away from the observer. We observe that frequency will decrease, right? But that is not happening in our situation. Okay.
so then,
Okay, let's suppose we are having a bike over here, right? And we are having a rest or stationary observer over here, right?
okay,
Initially, we are having a situation that we are moving towards the observer, right? And we solved that part already, and there is nothing special about that. Okay, so we reach this point. Now we are going very close to the pedestrian observer, and we are going to cross that observer, right? And after passing away from the observer, we started our second phase, that we are going away from the observer, right? So when we are moving towards the observer, so the quantities will be like this, that your frequency will increase, but your wavelength will decrease, right?
okay,
Okay. And when we are going away from the observer, so your frequency will decrease, but your wavelength will increase, right?
yeah,
But in question, from the last line of the question, this part, the pedestrian now hears a sound that is increasing in frequency, right? And before that, it is mentioned it is moving away from the observer, right? So when we are talking about away from the observer, so your frequency will be what? Decreasing, right?
yeah,
This is the original condition, right? This is the original state that we studied in the law effect. But in
yeah,
question, that when it is moving away, so you are getting increasing frequency, but we will get a decreasing frequency in according to the law. So this is related to the question, that in question we are getting that your frequency is increasing. It means your wavelength is going to be decreased, right? So they are
yeah.
state the variation, so they know that there is a change in the question. So they are asking that what will be the change or what will be the variation, that frequency which is going to be decreased, but now it is going to be increased. So why it is increasing? So they are asking about that question, right?
What they're saying is that, what they're trying to say is that the speed will not be constant
Yes.
and the
Yes.
frequency will change, but the wavelength is constant.
Yes. So basically initial speed is 13. So it means that now it is not moving 13. So when we are passing from the observer, let's suppose if we consider that same example of having a lift from some other vehicle. So when you ask for a lift, so someone just crossing and observe you, then he applies or she applies brake and it will stop after some distance. So in that scenario, our speed is decreasing, right? So when we decrease our speed, let's suppose this bike is passing through this point and suddenly it stops over here. So that frequency which is increasing will be constant because now you are not moving, right? So when you are applying brake, so your speed is decreasing, and when your speed is decreasing, so your frequency will not decrease, your frequency will increase, right?
Yes.
So that's why our speed is decreasing. Okay.
Okay.
Any confusion now?
No, it's clear.
Okay, because you need to compare with the original law or the original statement. That is only
Oh,
for 1 mark, but that is a conceptual one. Okay, this part is related from polarization. And a beam of vertically polarized monochromatic light. You know the concept of monochromatic?
yeah, it's light of a single frequency.
Okay, so it is incident normally on a polarizing filter as shown in figure 5.1. This is our original intensity I naught, and it is going to pass through a polarizer. Yes, this is polarizing filter. This is not analyzer. And the second thing is we are getting intensity IT after passing through the polarizer. The filter is positioned with its transmission axis at an angle of 20 degree to the vertical. The incident light has intensity I naught and the transmitted light has intensity IT. That is already mentioned in the diagram. We observed that part. Question is, by considering the ratio I over I naught, calculate the ratio of the amplitude of transmitted light divided by amplitude of the incident light. Okay.
Okay.
So basically, we need to calculate the ratio and we need to show the working. This question is of 3 mark, right? First of all, let's start with our basics. Basics is we need to use the formula I is equals to I naught cos square theta, Malus law, right?
Yeah.
And simply we just write I is equals to I naught cos square what? 20, because angle is mentioned in the question. It is mentioned over here, right? So
Yeah.
cos square 20 will be equal to
Cos 20 equals to 0.9396.
you need to calculate cos square 20.
Okay, wait. How do I make cos squared in the calculator?
You need to write cos, then square, then in bracket 20.
But like it's not letting me like write anything outside of the bracket with cos.
In scientific calculator.
Yeah.
Okay.
I'll just do it on my laptop then.
Or you just simply calculate 20, then you square the term.
I can do that. So if I do like cos 20 and then just square the answer of cos 20.
You are getting 5.
Yeah, I did that.
From
I
my
got 0.88.
yes, because that is something different because we know first we need to calculate then square. But this is cos square. Let me check. Okay, in your scientific calculator, first press cos, right? Then press square sign, then write
Mm-hmm.
20, then press
Then
OK.
I okay.
Cos, then square, then 20.
Okay. What did you get?
My answer is 0.8830,
Okay, I got the same.
right? Because cos 20 square is something different, you know that. So in
Yeah.
scientific calculator, because different calculators have different configurations. So, okay. So this is the intensity value, right?
Yeah.
And the factors that we know about the intensity, and one factor is related to amplitude. You know about that intensity is directly proportional to the square of the amplitude, right? That we discussed in our last class, this one. So they are only talking about the amplitude. So if we try to combine it with that concept, so your concept will be like, we know that I is directly proportional to a square, that is amplitude square. And the second thing is that I naught, let's suppose the intensity of the original one is equals to, or we just simply write it like that, I naught is directly to a square. And if we just shift these values, and I'm just removing that directly proportional sign, because we are only talking about intensity and amplitude, we are not talking about the frequency, right? So if we shift and convert in this form, let's write it it at a naught. So if we want to convert, so it will be at over a naught whole square, because we are having square on both amplitude, and that will be equal to it over I naught, right?
Yeah.
So basically, from the first part that we already calculated 0.88. So if we convert that one also, I over I naught, right? So it will be equal to what? 0.88. So it means that I over I naught is equals to what? 0.88, right?
Yeah.
So this is our equation number one. Just we say that, and this will be equation number two. So this value can be substituted in equation number two over here, right? So that will be equal to 0.88 is equals to a over a naught, or at over a naught is equals to 0.88, because they are asking about the ratio of amplitude, right? So basically this statement is also equal to the transmit divided by the incident, right? And now we just need to under root 0.88. So the under root of 0.88 will be equal to it is equals to 0.93 and round of 0.94. Are you getting the same?
Yeah.
Okay. So we just need to under root this value. So that will be equal to 0.938, and after round of the value you will get 0.94. Okay.
Okay.
So you need to also do some type of mathematics,
Yeah.
because this is completely related to your mathematical calculation, right?
Yep.
Because you know the concept I is directly proportional to a square, but after that you still need to do uh, extra work for the final answer. And I think it is not difficult, right? Because this
Yeah,
is
it's
the
not,
first time. Yes.
it's practice.
Yes. Okay. After that, in our final question, the filter is now rotated. Yes, this type of questions are again confusing because the statement is too much lengthy and only for 1 mark. Okay, now filter is rotated and about the direction of the light beam from its starting position. The direction of rotation is such that the angle of transmission axis to the vertical initially increasing. So it means our angle, which is initially 20, now it is going to be increasing. And they are saying that calculate the minimum angle through which the filter must be rotated so that the intensity of the transmitted light returns to the value that it had when the filter was at starting position, right? The question is in simple word, I will tell you what they are asking. Let's suppose initially we are getting intensity 10 at 20 degree, right?
Yeah.
And now we start changing our angle because that is the demand of the question, right? Now we start rotating. It is mentioned that angle of the transmission axis to the vertical initially increases. Now we change the angle. Now you again need to find the minimum angle. Minimum angle means there will be different angle where you are getting same intensity, right? Okay, because from 0 to 360 there are many possibilities of different angle that you will get the same intensity, right? Just like if we draw this orientation, so on this point and this point, on both angle we are getting same values, right? Because particles are going to be vibrating up and down motion, right? Are you getting?
Yeah.
Okay, so basically they are asking that if we change the angle, so you need to find out that minimum change in angle where you will get the same intensity of light that is in your starting position, just like mentioned in the diagram, this one. So now we need to change the angle, and we, after changing the angle, you need to find out the new one where you are going to find the same value, right? And I already gave you a hint. Let's suppose if this point or line will be in this direction, right?
Yeah.
Let's suppose if we are on right hand side and if we move on our left hand side, so we are still on horizontal plane, but the difference is our direction is opposite, right? Okay, let's suppose there are four people standing in a row and they change their position, so their angle or their rotation will be changed, but still they are in horizontal position, right? So same
Yeah.
goes for this position. You need to extend this line only like this. Just extend this line. Okay.
Okay.
And what you will get over here? Now again, we need to measure the angle, and you know the concept of that normal line, right? We need to draw a normal line to measure the angle, right?
Yeah. Yeah.
So if we measure angle normal line, so this angle is 20. So this angle will automatically be equal to what? 20,
70.
right?
Wait, this one? Okay. Yeah. Okay.
Yes, because that is in the opposite direction. And if we consider this blue line, so actually this blue line makes 180-degree complete, right?
Yeah.
But 20 degrees subtracted from this point and 20 degrees subtracted from this point. 20 is already over here, 20 is already over here. So it means how much change or what is the minimum angle we are getting from this center point? This angle only. Because we know this complete line makes 180. So 180 means minus 20 this one, minus 20 this one. So we are getting what? 140. So we need to move 140-degree and this is will be the minimum change, right?
Okay.
Because you know in opposite direction that was the first time we will get the same value, right? So this will be the minimum angle. So initially we are at 20 and we need to find out the next 20 on the opposite side, right? So this 20 is already covered. So we are not going to count that one because that angle is for the intensity, to calculate the intensity. So this angle is not included in our calculation. We just need to find this angle. And we know this whole line is equals to 180. So we need to subtract these 20 on both sides. So we will get 140-degree. So after moving 140-degree, what is actually they are saying that we need to move 140-degree from this point to this point. So you will get the same intensity of light as the original one, right?
Yeah.
Okay. So the angle will be equal to 140
Um,
degree.